So in this question, we have this element here, and we're given the average atomic mass of that element, and we're told it has two naturally occurring isotopes, and we're only given the percent of one and the mass of one of them, and we're asked to find the mass of the other isotope. So because this has only two naturally occurring isotopes, and we have the percent of one, we can find the percent of the other one. And so the percentage of the other one is going to look like this. If we know that the isotopes are going to add to 100%, then if we do 100% minus the 57.3%, we're going to get 42.7%. And so this right here is going to be the percent of the second one. And so now we just need to find the mass that corresponds with this one. And so the equation that we're going to do to find this is going to be that the average atomic mass, mass, that's going to be equal to, we're going to take the percent of the first one, and we're going to multiply that by the atomic mass of the first one, and we're going to add that to the percentage of the second one, and times the atomic mass of that second one. And if we had more than two, we would just keep on doing this over and over again, and we just add them all up, taking the percent and its corresponding atomic mass, and they would go together, and then we just keep on adding them up. But because we only have two, I'm just going to stop right here and say, okay, it's going to be this one right here and then this one right here. And so what I like to do for these types of questions is I like to underline the numbers that kind of go together. And so you can see here, this is the average. This is going to be the number that's on the periodic table. And if they didn't give this number to us, we can easily just go and find it by find it on the periodic table. But because they give it to us in the question, I'm just going to go ahead and write that down right in here. It's going to be 121.757, and that's going to be equal to, we have the percent of the first one. So let me go ahead and underline that first one. We have this one here, and this number right here goes with it. And when I do this percent right here, I want to make sure this is going to be in a decimal form. So I'm going to go ahead and convert that to a decimal. That's going to be 0.573, and then the atomic mass of that 57.3% is going to be this 120.904, and then we'll go ahead and we'll add that to the next one. Now this is where we don't know what the mass of this one is, right? We're looking for the mass of this, but we do know the percent. The percent is going to be this right here. And so what we'll do is we'll convert this percent right here to a decimal. That's going to be 0.427, and then we don't know what the mass is, so we're just going to put an x in here, and we'll solve this for x. And so all we got to do now is just solve this equation out. And so that's going to be, let's see, we got 121.757 equals, when we multiply these two numbers together, we're going to get 69.2779, and then we're going to add that to this number times x is going to be 0.427x, and then we'll subtract this 69.2779 to this side, and we'll subtract the 69.2779 to this side, and then we're going to get let's see, 52.4791, and that's going to be equal to this 0.427x, and then we just divide both sides by this 0.427 right here, 0.427, and that goes away, and then we got 0.427. So we're going to get x is going to be equal to 122.901, and this is going to be atomic mass units. So let me put that unit in there, and then this right here is going to be the answer.